You know, sometimes a world-changing idea isn't some big, flashy product launch. Sometimes it's hidden away in a dense academic paper, just kind of waiting for the world to catch up. And that's exactly the story we're going to dig into today, with what might be one of the most important papers in the history of AI.
First, just look at this number, over 9,000 citations. Seriously, let that sink in. In the academic world, that's not just a big number, that's huge. It means thousands and thousands of other scientists have literally built their own work on the ideas from this one single document.
And that gets us to the big question, right? The paper was published way back in 1997. 1997. So how on earth did something written before smartphones were even a thing become a foundational pillar of the AI that we all use every single day?
So here's how we're going to unpack that. We'll start with the paper's hidden influence, then dive into the massive memory problem AI was facing. After that, we'll look at the new kind of memory it proposed, the breakthrough at its core, and finally wrap up with the incredible legacy it left behind.
Okay, first up, the paper's influence. Let's start with the basics. What are we actually talking about here? So the paper itself is called Long Short-Term Memory, written by Sepp Hochreiter and Jürgen Schmidhuber. It came out in December of '97. And check this out. Beyond those thousands of citations, it's been read by researchers almost 38,000 times. Clearly, something special is going on here. But to really get it, we need to understand the problem they were trying to solve. Because back in the '90s, AI had a really serious memory problem, a very specific type of forgetting that was holding everything back.
It was a major struggle with something called long-term dependencies. Now that sounds super technical, right? But all it really means is connecting the dots over time. For an AI to get context, it has to link something that happened way back at the beginning of a sentence or a story with something happening at the very end.
The best way to think about it is like this. Imagine trying to understand the twist ending of a great novel if you completely forgot who the main character was from chapter 1. It's impossible, and that's the wall AI researchers kept smashing into. Their models would forget that crucial early info, making them pretty useful for complex stuff, like understanding language.
So, it was obvious the world needed a totally new kind of memory for AI, and that's exactly what this paper delivered.
But here's the thing. It was not an overnight success. Not even close. After it was published, the whole idea of long short-term memory, or LSTM for short, was kind of this unsung hero for a decade. The world just didn't have the raw computing power to make it work. But then, come the 2010s, computers got way faster, its genius was finally recognized, and boom, the citations just exploded. It became a core concept in modern AI.
So what was the actual breakthrough? What made this new kind of memory so revolutionary?
Well, it all comes down to being selective. Old AI memory was like a sieve. It treated every single piece of information as equally important, so it just forgot stuff that happened a while ago. LSTMs, on the other hand, were designed to be smart. They could figure out what was important and keep a hold of it, creating a selective long-term memory.
And here's the basic idea, broken down into 4 steps. First, it reads new information coming in. But then, and this is the magic trick, it actively decides what to forget. It just throws out the junk data it doesn't need. Step 3, it remembers the important stuff, the key patterns, the context, and finally, it uses those carefully selected memories to make a much smarter decision or prediction. It's not just memory, it's managed memory.
So this all brings us to the legacy. Why does a nearly 30-year-old idea matter so much to you today? Well, because it's pretty much everywhere.
The concepts in this one paper were like a key that unlocked a door to a whole new universe of possibilities, from wild generative AI to the simple tools we use all the time. I mean, think about it. That predictive text on your smartphone that finishes your sentences, that's built on LSTMs. The magic of real-time language translation in an app? LSTMs. The ability for your smart speaker to actually understand what you're saying? You guessed it. It all traces back to this one core breakthrough and how an AI can remember things.
So, in the end, long short-term memory isn't just some influential paper. No, it is truly a cornerstone of the entire deep learning revolution that has completely reshaped our world. And that leaves us with a really fascinating question to chew on. The LSTM solved the memory problem of its time, and that's what gave us the AI we have today. So, what's the next memory problem AI needs to solve? And who, right now, is writing the quiet academic paper that's going to define the next 30 years?